The specific question is how venture capital firms can select partners during a syndication. Basically, venture capital will try to finance young entrepreneurs or new firms, and quite often they would be looking for partners for resources, to pool resources, to pool expertise. So there are about three parties involved. One is the lead VC firm, and the second is, of course, the partner. And so the lead is always looking for partners who can contribute to value, reduce risk, and enhance value. The partner will be also trying to see whether this is the right lead that they have actually selected. But they are also the firms that are actually receiving this venture capital financing for their entrepreneurship. So you can see that there is a lot of dynamics here among the three major parties to this deal. So, but the question, what has been difficult, notoriously difficult, is how to model the dynamics in the venture capital partner selection process, especially during syndication, putting funds under syndicate, so that the lead venture capital firm can select the very best partners. This question has been very difficult to model because the traditional econometric methods very rarely pick up the dynamics and the nonlinear relationships involved. So this paper is the first to look outside other methods and invoke machine learning methods to build a prediction model for venture capital partner selection decisions as part of venture capital syndication, and specifically drawing upon a lot of information on the firm profiles and on the transaction relationships, the network in the transaction relationships among the firms. Now, machine learning methods do involve quite a large number of sub-elements or the machine learning family. And we pick on one of those, which is the deep learning, that is based on artificial neural network algorithms. And those are specifically designed to capture dynamics and nonlinear relationships. We are fortunate to get access to data, specialist data, privileged data, and pull together quite a huge database of 10,254 transactions with 264 potential candidates and more than 130 decisions. The paper is specific to China. Now, in the process, again, part of the storyline, we uncover 4 new findings, which add a lot of dimension in the literature. The first is to show that the machine learning approach we invoke actually successfully predicts partner selection decisions with a high prediction accuracy of 99.32%. And so it is to demonstrate that actually the approach works. But secondly, we uncover results which are able to shed a lot of light on some of the controversies that have been in the literature. For example, the role of industry experience, and also the fact that there has to be some amount of high reciprocation between the lead venture capital firm and the partner firms. We also find that actually signal extraction problems signal extraction does matter, and especially in getting the firms to cooperate, so that the venture capital firms will cooperate at actually later stages of development rather than in the earlier stages. And that seems to shed a little bit of light, but also clear some of the controversies in the previous literature. We also bring onto the table the issue of discussing state-owned enterprises in China versus those venture capital firms which are not state-owned enterprises. And the expectations would have been that because of politically connected firms literature, that maybe the SOAS, which in China would be very powerful and would give strong signal to lead venture capital firms to be selected. No, on the contrary, that's not the issue. That actually the strong signal comes from non-SOA, non-state-owned enterprises venture capital. And we argue that these new findings have important application in terms of guiding firms on A, if they are leading, how to select a partner, B, if they are partners, how to evaluate the leading firm, and C, if they are just looking for financing, how to see the dynamics between the leading firm and the partner firm. Okay. So I will try to follow a pedestrian roadmap or route map. I just a little bit of a discussion on what do we know, the literature, and go through some of this. And I just want to thank a colleague at Warwick for mentioning some of the literature that people tend to sidestep in this work. I'll then look at some of the underpinnings of the theory, summarize the underpinnings of the theory that works with respect to this strand of work. I will then go to explain the methodology, in particular the data, the machine learning approach, and how we are using this to build the venture capital net architecture. I will then discuss the results we obtained, and then conclude, look at some of the takeaways and implications for policy and directions for future research. Okay. I'll keep on monitoring the charts just in case you have some comments. Okay, what do we know? And this is the literature. The major issue we start with is to say that, to realize the important role played by syndication. And the syndication of all types is very important in investment performance, even and uncertainty. And the work, especially by Liu and Moller, Cummings 2016 and others, and Kemamo 2016, draw out the significance of in investment performance, whether you are looking at alpha adjusted, beta adjusted, any aspect of investment performance. Syndication alters and to alter the standard interpretations. But the question is simply that one, that it is very difficult actually to choose a partner. How do you select the partners? And how will the lead, in this case, how will the lead venture capital select partners in order to be able to reduce risk and enhance value? But as we know, the first insight comes from signaling. And this goes actually back to the work of Nobel laureate Spence, 1973. But Spence was applying this to labor markets. But the signaling literature, of course, goes to the Island Empire, but this application to banks, okay? And in actual fact, from banks, any theory of banking intermediate you face has the Leyland Empire as the important theoretical underpinning of the role of signaling in banks and also in financial markets to be able to reduce information asymmetry. And a new work, especially Hoban, has extended this work of signaling to cover most financial markets. But it is the work by Coates and others, 2001, which brings out the aspect that actually signaling is specifically important, especially for observable signals, which the lead venture capital firm can use to reduce information asymmetry and infer the potential quality of the partners in the syndication. So signaling becomes, particularly important. But it has also been shown by some of the new work that the quality of the venture capital firm is mainly revolving around the reputation of the VCs. And especially the work of Mangard is very important, who emphasizes reputation. But Casamanta and Harichabad go a little bit further and say it's not only reputation, but it's also experience, which provide very important and valuable signals for the quality of venture capital transactions. But we should note that this literature is also awash with a lot of mixed evidence and some disagreements. It's actually not disagreements that concern us in this story. It is the fact that the literature uncovers quite a number of potential determinants, potential explanations of how venture capital leads can choose partners, and also how they can use the dynamics to be able to help firms that are looking for finance. And a number of these, just to pick on some of them, Harden, for example, emphasizes prior ties, prior transactions, prior organizations, that because of that, of the prior ties and prior collaborations, this would help to mitigate conflicts of interest and risks. Okay. However, Mora goes a little bit further and say, when you are looking at cross-border VC syndication, that these foreign firms would be looking at identifying local firms that have clear understanding of the firms that may want to raise money through VC, and that would reduce the amount of uncertainty. Okay, so cross-border venture capital firms will partner with local firms to be able to reduce the amount of uncertainty. But this literature also goes further to say, well, that may be true, but also the lead venture capital experience matters. If a lead venture capital firm realizes that it actually understands the market, may be able to understand the market much more than the local firms because of the nature of expertise and experience in the firm. So as we can see, prior ties have been identified. Involvement of local firms have been identified. Experience of the venture capital firm has been identified. But in addition to that, Hope in 2010 comes up with a new insight of saying, theoretically that will be the lead VC only invite partners only in cases where they face higher risks and long capital burdens. Okay. Otherwise, they may not be able to entertain any new partners. And that's an additional factor. But an additional cofactor is identified by Kaiser and Lutbach, who argue that when VC investments go worldwide, they are actually looking for diversification benefits. And diversification is one of those areas that actually dominate international transactions. So VC will fund size and investment experience that these are normally correlated with the syndication probability. So diversification may work, but has got its limitation. In another extension of Copes and Lucas, what these do is for the first time try to put together, to bring together a couple of these factors. So they capture, and as the first study, to capture several characteristics together. And however, they capture only 3 characteristics. First, the collaboration history, just like prior ties. They also capture the portfolio firm's age and the portfolio firm's size. So as you can see, the first gap is that none of these existing studies so far has been so comprehensive in bringing together all these important factors captured in the literature and to try to investigate them together and be able to identify which ones do matter and which ones possibly are secondary. And the reason why this has not happened, because there is a big barrier in terms of a methodological challenge. The barrier being that some of the traditional tools we have in regression analysis and in a parametric econometrics may not be able to deal with the dynamics of all these factors brought together, and that the methods being used, especially logistic regression, can only work well for smaller data sets and limited number of variables. And this observation is very well made by a paper by Parik and others in 2003 in the Journal of Finance. So we have a second gap here, which is that conventional techniques are often limited by the strict assumptions, normality, linearity, variable dependence, and for that matter, they may not be able to capture dynamics and nonlinear relationships, which are typical of partner selection in venture capital syndication. And that's why this problem has persisted. So what this suggests is that we possibly need to look outside the conventional tools that have been used in this literature. And that's precisely what we do. We look outside for other tools, and we're pleased to see that actually machine learning techniques such as neural network analysis are widely used in the literature to model partner selections in business economics or in managerial economics, in management, in finance. For example, the paper by Lau and others, 2001, propose a computation intelligence technology which can benchmark the business partners based on case-based reasoning and neural network. And they also develop a prototype, test a prototype, and validate the proposed system. But also outside the venture capital area, Sari and others in 2008 employed analytic hierarchy process model for the selection of partner companies in virtual enterprises, and come to the conclusion that the model they put together is not only suitable for partner selection, but also for other applications, including other applications of finance, perhaps in venture capital. We could see others who have worked within the domain of machine learning techniques as a family of our techniques, and especially the paper by Wu and Barnes, who propose a new fuzzy intelligent approach for partner selection in supply chains. They combine feature set theory and radio basis functions, artificial neural network, and are able to classify potential partners using very large amounts of mixed methods, that is a mix of qualitative and quantitative data. So here is our gap number 3, that to the best of our knowledge, and I stand to be corrected here, but the best of our knowledge, these machine learning methods have not been applied to model partner selection problems in venture capital syndication. And that's why we claim that ours is the first paper to do this. So just in a summary, the contributions are revolving around this. First one, we address gap number one by looking at the collection of several signals which influence venture capital partner selection together. VC partner characteristics, lead VC characteristics, and the characteristics of the firm, and to do so by allowing for nonlinear influences. In terms of the theoretical contribution, we actually bring together two strands of literature: the literature on signaling theory, which I have just reviewed, and the literature on VC partner selection. And we use both literatures to be able to bring together the framework that we investigate in this paper. We also address gaps 2 and 3 by invoking deep learning, artificial neural network algorithms, to efficient and effective remodel scenarios of partner selection in VC syndication, which would otherwise be difficult, impossible to model by traditional regression methods. We also use big data, and I say big in quotes because it could have been much more than this in terms of data. So we use a big data set of from China that I explained at the start of the discussion, and then we're able to obtain new results. But further than that, we find that the machine learning methods will need to be complemented by ways of being able to obtain some coefficients, parameters to explain the extent of the relationships. So we use rare events logistic regression, which I'll explain in a moment, to identify the exact factors which influence the partner selection process and cover those findings that have so far already summarized. Okay. So let me just mention a little bit about the theory. And in the drafting, this is the way we configure the hypothesis also in this presentation. I'm not stating them as hypotheses. But there are four important aspects of the theory. It is start by understanding why lead venture capital firms, they need to partner in order to get resources and also to get complementary skills. That is expressed in Harrison's paper, Harrison and others, 2001. However, in China that we're investigating, the network and Guanx, I hope Jun Hong, I'm pronouncing this correctly, Guanx, the connections, we know that they are significant for business development. The paper by Jagger and Liu, 2004, have mentioned. So experienced VCs, accumulated network, and knowledge are important signals for partner VCs quality. And hence, it is can say that the extra investment experience of VCs, and this is a technical discussion, and we're just gonna explain this, the VC's extra investment experience, which actually refers to how much more experience the partner VC has than the lead VC. So the partner has more experience than the lead VC, and that's why they're selected. And that's the VC extra investment experience. Okay, that's what the theory is. So that increases the possibility of being selected by the lead VC for syndication. So to be selected as a partner VC, you actually need to be able to beat the experience of the lead VC. But then the theory says it's not only the investment experience that matter. The syndication history will matter. And this arises from Beckman's observation that sometimes newly established VCs try to obfuscate the market. They invest massively, they make themselves very visible, and they take advantage of the opacity of the market. Okay. However, as we know, VC investment has a long time horizon, and the failure rate is quite high. Some of the projects fail because of managerial skills. They also fail because of bad luck. And indeed, Robert Creasy always points to this in the Valley of Death, that they don't survive, in the first couple of years. So the lead VC and the partner VC syndication history will be a better way of assessing the quality. And hence our argument here is that the VC's visibility and position will increase the possibility of being chosen by lead VC for syndication beyond the extra investment experience. But theory also points to reciprocation, and the work of Anderson and Weiss 1992 actually explain what is meant by reciprocation. That basically, if a lead VC selects a partner, the partner, when they have the chance to become a lead VC, they also choose the previous firm that was a lead VC in a previous transaction. That's reciprocation, and it's built on trust. I'm sure that Reinhard, somewhere in the audience, will find sympathy with this argument of reciprocation and trust. So we argue here that by repeating reciprocation with each other, the trust between VC firms, the lead and the partners, will also be enhanced, and the deal flow can be maintained. In theory, these VCs do not work in a vacuum. They work in a political environment. And so just extending the work on the political economy, Leonard Wanchekon and others powerful here, in looking at the politically connected firms. And we argue that in the case of the Chinese firms, it is vital for farmers to have a good guanx with authority to gain access to core resources. And so we argue that the state-owned enterprises, VC, have inherent strengths than non-state-owned enterprises in aspect of guanx, which will lead to higher profitability, better network, as low as lower risk. So you possibly hypothesize that a state-owned enterprise VCs could increase the probability of collaboration significantly. But it may well be the case that because VCs operate in a highly private capital arena, that they need a signal for credibility, and maybe the opposite is true. Okay. And so this is a summary of the kind of theoretical underpinnings which basically underpin the construct of the work that we're doing, and we're going to rephrase this as a hypothesis developed from the literature. Okay. The first part of the methodology I'd like to present here is just about understanding the spatial data that we're able to access. The data was drawn from CV source database. It's not VC, not venture capital source database. It is CV source database, which has records for VC investments in China. This is possibly the authoritative database, but also we use this database to create a comprehensive database of VC investments in China from 1989 to 2016. We have data up to 2019, but it's just unreliable and incomplete. So that's why we make a cutoff to 2016. And from the 15,410 investments. We exclude projects with incomplete data and those projects that actually only focusing on angel investment and the PE investment, which is a different, financing mechanism altogether. And this leads us to 10,252 investments and 6,400 portfolio firms. Now, to ensure variations in the key independent variables over time, we only include the most active VCs for the list of partner VCs. So the partner VCs has to invest at least 10 projects in the sample period. And so this narrows down to 264 potential partner VCs and more than 130,000 decisions. Say, for example, if one of the 264 VCs is chosen by the lead VC for the underlying projects, decision would be 1, and all the non-chosen partners would get 0. Okay, so that 1-0 entry gives us the impact, the partner selection decision that we need to use for to study the impact of the partner selection decision. Okay. In this database, we note that the lead VC, the definition identification of what is the lead VC and what is the partner VC, which are the followers. We use the classification developed in Hochbach and others in 2016, and it defined the lead VC in terms of 3 important factors. 1, the VC that has the largest investment in the project. 2, in case more than one VC have the same large investment, we apply the first in, first served rule. So we take the one which came first. But 3, in case more than one VC invested in the same round with the same investment amount, the one invested the most times would be the lead VC. And that's how we select the lead VC, and there has to be the partner firms. Okay. And what I'm going to share with you in table 1 gives us a summary of the variables of interest here, consistent with the literature that is summarized and the views that I summarized. So if I can use my cursor, if you understand here, we mentioned the important factors, collaboration factors, the extra experience, the number of investment a potential partner has made with the potential industry of a number of over the number of investment the lead VC has made in that industry. Joint history, the time of syndication between a given VC and a potential partner. The tie here is capturing reciprocated ties, the times that the lead VC and potential partners have invited each other in a project. And about the pins are the trust element that I did mention. We're also able to pull together information on the lead VC and then appetency characteristics. Now, this has been difficult to capture in the previous work, as I did mention. But we capture these dummies with dummy variable equals 1 if the lead VC is government-backed and otherwise. And VC type equals 1, dummy variable equals to 1 if the potential partner is government-backed, VC, or otherwise. Lock, dummy variable. So if the partner VC is located in the same province with a project firm or otherwise, or 0 otherwise. Cluster VC, the dummy variable equals to 1 if the potential partner is located Beijing, Shanghai, Shenzhen, and others. And also here we are able to capture the other variables like age, syndication, and the size, and also the characteristics of the portfolio firm in which the lead VC and the partner VC invest. Okay, so we are interested in round of financing, and the stages of financing: early stage, expansion stage, and late stage. Okay. And when we put together the data, that's precisely what we find. As you can see on that table 2, the mean, here where I have my cursor here, the mean extra investment experience is 0.002, which indicates that the partner VC has relatively high experience than the lead VC. It confirms the resource-based view or the extra experience view that I mentioned when I was looking at the theory. In addition, the average syndication history, which is here, is 0.013, indicating that previous interaction is an important component for partner selection decision. So for the 0.03, reciprocated ties suggest its importance in partner selection decisions. And again, we can look further into the investment stage and find that early investment has about 58%, that is here on the early stage. Expansion, 30%, and late stage, that is just less than 1%. And so, these are some of the statistics, are well behaved, but the mean also makes a lot of sense with a high number observation and low standard deviation. Okay, so let me now go to explain the way we approach machine learning. First of all, just to state that this is an increasing trend. The trend is on with more applications of artificial intelligence technologies to predict business relationships. The neural networks we use in this paper are a specific set of algorithms that have revolutionized the field of machine learning. Okay, and here the neural network is used to model dynamic or nonlinear relationships of interdependent relationships, and not limited by any other assumptions like numerical assumptions, which make it difficult, impossible for traditional models. Okay. And we also probably because in the Bayatov's paper of 2003 by Vatov and others, it is shown that neural networks generate better performance than traditional statistical methods such as ordinary squares or logistic regressions. And this is work in business connections, not necessarily on venture capital, but they do actually a kind of the accuracy of the modeling. And also to observe that in the area of finance, these neural networks as part of machine learning have been applied in many topics. And we cite only 3, for example, the paper by Chen et al. In 2009, which look at supplier selection. The paper by Ghosh and Reed in 1994, which looks at credit card fraud detection, and the paper by Lai and Lai 2011, which looks at stock price prediction. And the important point we make here that in this particular paper, in our paper, we apply machine learning, we apply neural network methods to model venture capital partners based on the on this literature that shows how this approach is particularly helpful in modeling in other applications, and will give us a clear advantage in modeling VC partner selection. How do we do it? We basically invoke and to explain here the architecture of our VC selection network, which we call VC net. So the venture capital selection network here, we develop this as a deep machine learning model based on fully connected neural networks. Okay. And the whole rationale is that a well-trained deep model should be capable of producing the probability of a given lead VC making a positive decision when it's given all the data regarding the lead VC, the followers, and the underlying firms. With all the data, be able to present this as a vector in the input of the prediction model, and then generate the predictions. Okay. These features or the input data are firstly normalized and then mapped onto the range of 0, 1, depending on how they align with the various components of the VC or follower or firm. And then the discrete patterns are categorized. They run a category that goes in a sequence. Effort is made to follow Gaussian distribution. And so any departures like Gaussian noise would be applied to continuous and discrete features after they are normalized, which would be at improving the training robustness. In other methods like non-simulation, they just basically on residuals, the white Gaussian noise residuals, to be able to add them to be able to do their forecasting and perfect tracking. Okay, so it's just almost analytically the same type of procedure. And the proposed fully connected neural network consists of a number of layers in a structured manner. The first layer, and then the last layer, which then are connected and interpreted. In fact, if I could highlight, yeah, you have something like this. The architecture of our VC selection network, VCNet, is structured in this way. And where you have a simple framework of interconnectedness, fully connected neural network, in which the number of layers, okay, M is equal to 3, have 3 types of layers. The number of neurons in each are, say, in this case, are 5. In N2 are 6, and N3, 3. Okay. So such architecture is simplified to be a 5-6-3 configuration. And the lines between the layers are transformed weights of W, W, and B. Okay. And the ratified linear units are utilized for each layer beside the last one activation function, and then the linearity is engaged to produce the probability. And this, so you have inputs and a final version that goes into the output here. And basically, that's how. And the line is here, the line is trying to capture the amount of interconnectedness. In fact, this architecture of the VCNet could be captured as a function fx equals wx plus b, as I mentioned, where you have a w in the weights between the layers of the weights w and b, where x is the output of the previous year. So x is the output of the previous year, and w and b are parameters to be learned to build the affine transformation. Okay. The training of the neural network is actually the minimization of a specific objective function. And the objective function here is the loss function. Okay. And we're going to see how in our model, how we realize the loss function here. We just see the amount of entropy that we generate in our model. Okay. And there can be some problems of overfitting Okay. And so the idea is to keep on feeding in the data. The weight decay regularization is applied. The initial learning rate is set to be at, say, 0.0001. Okay. Okay. And it's similar actually like to simulation. And then it is decayed exponentially after each training epoch, after each training round. And the training is terminated when the objective function converges in the software. Okay. So specifically in this, we are able to consider all possibilities of interconnectedness. The data set is divided into the training and we test randomly. The ratio of both sets is set to about 4:1. The dimension of the data is about 25, consisting of both continuous and discrete features. And so we are able to generate some deep architectures and evaluate them. For example, 64 neurons, and then to other layers, to 64, 128, 258. You can expand, and in the diagram here, you are looking at the 563, but you can end up on 64, 128, 64 is the maximum that we experimented with in this structure. And you actually, there are all types of softwares that can do this. For example, one of the ones we experimented with was the Google TransFlow Deep Learning Library 1.5 to be able to work out the configuration of the neurons. In fact, I should point out that if the neural networks are removed, you can actually you can condense this framework into a logistic regression model. But let me highlight here the future design we use. So we model venture capital selection as a machine learning problem, as I mentioned in that chart, in which we aim to predict the cooperative relationships between the lead venture capital, XA, the follower or partner venture capital, XB, given the input XA, XB. So we denote an algorithm of that specification, where M represents the features of the lead venture capital, XA, and N represents the features of the partner firm or a follower, XB. And basically, our goal is to build a model rating venture capital firm pair, XA, XB, lead and follower, so that the lead follower relationships can be captured through neural network classification. Okay. Now, in designing this model, we are able to capture all the factors we reviewed in the literature. I remember we were mentioning that one of the reasons why traditional methods were not able to capture this is that basically you could only capture on a couple of characteristics. Okay, we capture the full array of those variables in the literature, and just summarize these here, because we have looked at them. Just summarize them here. The data is featured in the model. It captures the VC extra experience, which we looked at, the history of syndication, which we looked at, reciprocation and trust that we looked at, the type of the VC. We made the type of VC as 1 if the potential partner is local VC, and 0 otherwise. The portfolio firm geography, we score 0 if the lead VC does not locate in the same province in China, and 0 otherwise. The VC background, we measure VC background as 1 if it is a state-owned enterprise, and 0 otherwise. The VC size, we include VC managed portfolio, a logarithmic. VC age, we take the same definition as ages in corporate finance. A part of VC age is calculated from the founding date to the year of the co-investment. syndication size, the total number of VC in the syndicate. Investment stage, there are 3 stages I mentioned earlier. The seed stage, the R stage, it's just we can break down even into, instead of R, mid, and so forth, into seed stage, R stage, expansion stage, and a later stage. Each of these stages is given a value of 1 if the portfolio firm is in that particular stage, and 0 otherwise. And then the financing round, we measure round by the ordinal account, 1, 2, 3, and so forth. And the investment year, we include the year, the investment year in the model, which is measured by the calendar year investment. So the models capture all these important facts here. And then when we actually use this model, we are able to use to evaluate the predictive accuracy. And let me say here that we could use different measures. For example, I know that the work that Yoshi, who is in the audience there, say the work that he was developing since the start of I think last year, because I have seen a lot of the papers he's doing as part of the Center for Global Finance, he's able to expand. We expanded and put in all measures of predictive accuracy. And here, we actually only focus on 1 or 2 measures of predictive accuracy of the model. We could expand them to about 6 or 8 in the standard literature. Here, we just measure predictive accuracy in terms of the number of corrected predicted entry, the number of total testing entry as a percentage. Okay. What did we find? Now I'm gonna just go through the results very quickly. I don't know how I'm doing for time, but I suppose I should be okay, man. And the first is to explain the results of the accuracy of partner selection model. Okay, we could have gone to this extent of using ML and neural networks algorithms, only to find that the model cannot predict partner selection decisions. Okay, but the results we get are produced here on table 3. Okay, the model prediction accuracy are produced in table 3. And this evaluates several deep architectures, possible architectures. On average, the prediction accuracy by neural network is about 99.1%. And that's the average, which is already high, in which the accuracy of the single layers are 99.29, as given here, 99.5 as given here for the layer of 6, 4, and 1 to 8. And 99.5 here is, sorry, 99.5 here is given for the neural network layer 1, 1 to 8 for the 128 neurons, and 99.29 for 64 neurons. The accuracy for the 128/64 is 99.35, as you can see here. And 256/128 is 99.43. And the accuracy of 97.95 is obtained for 64, 128/64. So we note here that the neural network without any layer, which would be say like the non-linear logistic regression, would have an accuracy of about 97.82, which is here. This has no layer, so it translates to like a logistic regression non-linear form, but it's the lowest among all the layers. So neural network without layer or too many layers has the poorest performance. So we can, on this basis, really emphasize that the highest prediction is obtained using the neural network predictions. But we could also evaluate this in terms of the training loss. As I mentioned, the loss functions, the cross entropy. And as you can see on this figure 2, that basically the cross entropy loss is high, but as the training iteration increases, this falls dramatically. And actually, you get the lowest somewhere after about 8 training iterations. Okay, these are training iterations times 10 to power 6 for each. So it's just simplified to give the visual idea. One other way of looking at this is in terms of the prediction accuracy, and I think this is what we have used with the Yoshi Shivima at SOAS, is in terms of looking at the mean square error prediction accuracy. And as you can see here, the mean square error declines for the training as well as the test. As you increase the training iterations, the mean error square actually reduces, showing the high predictive accuracy of our model. You can even capture this, the accuracy, in terms of the model itself. Okay, and here you have the highest accuracy after so many training iterations, obtained as you increase the number of training iterations, almost to 100% accuracy. So we can conclude, therefore, that the neural network model, the VCNet, is accurate and provides a high degree of accuracy in partner selection. Now, we can also check this accuracy by looking here in table 4, where we have 4 real lead VC decisions. And in each case, as in the table, comparing the actual decision and the prediction decision. Okay. In the example we see portfolio farm. So portfolio farm 1, which is initiated by VC1 here in this section by VC1, and co-invested by VC10. And basically, we see our results here that basically the actual decision is yes, the prediction decision is yes. VC11, actual decision no, prediction no. VC12, no, no. So again, we see that the lead VC, okay, we get high prediction accuracy for our model for the lead VC1, okay. In example number 2, we have the lead VC59 in project 120. Okay. And we note that basically, even the actual decisions for VC10, 11, 12, 68, the actual decisions are consistent with the predicted decisions predicted by the model. Completely consistent. Even in example 3, where we are taking VC2, again, we see the same. In example 4, where the prediction accuracy by lead VC200 in project 1043, now we could have project even 1000. I'm just only picking 4 examples here. The actual decisions and the prediction decisions are the same. And therefore, we have finished the checking and say we can, the prediction accuracy is very high with using this model. Now, I just want to make an observation that the neural network models we have used are able to give projections for lead venture capital in the selection of the partner VC. It captures all the mappings. However, it has one limitation. It does not generate the coefficients of each feature considered in the VC net, as would be generated, say, by a traditional regression model. Okay. Because the traditional logistic regression would possibly give us the factors, and then would also include the coefficients. So we need to be able to augment our ML model with some estimation technique. And here we estimate the coefficients using the rare events logistic regression model, which was developed by King and Zheng in 2001. With a bit of kind of modifications, but this rare events logistic regression model is able to capture a multitude, okay, of possible variations, possible reconfigurations of the binary dependent variable with dozens of thousands of times of fewer ones than zeros. So there's the kind of non-invents, invents versus non-invents. And this is why the methodology, this is the methodology that we invoke to be able to do further econometric testing, leading us to table 5. Okay, table 5 here summarizes the model that we have just put through the ML. Okay, the results, the estimation results for that model, taking into account all the factors that we're considering. I apologize that they have strained your eyes on this, but let me just highlight. Remember where we are looking at extra experience, okay, captured in terms of the experience of the follower or partner VC over the lead VC. That becomes very important. So the theory got it kind of right. It's very important in explaining the VC syndicated partner selection and important significance. And so is joint history also very important, and that's consequence theory. The tie, the trust, and the tie of reciprocal considerations are also important, even when you actually interact. The extra experience with the trust and reciprocal tie becomes very important. Okay. The other factors, which are the characteristics not previously captured in previous work, together is also come out important. There are some which follow like round and cluster, but in almost of the observations are particularly important. Now, we also try to take this regression model and allow for other possibilities. Could be robustness, could be just extension of this. And what we allow for is to allow for the split of the possible outcomes, as there are two possible outcomes. One could be a successful fund or could be fail, okay? And we want then to re-estimate the model, allowing for these two possibilities. For example, in model 1, 3, and 5, we show the coefficients for the extra investment experience being positive and highly significant for the success projects. But the coefficients in models 2, 4, this model 2, 4, and 6 of extra investment experience for the failed project are not significant. And so what this is actually, it's supporting the complementarity of resources and skills are very important. This is supporting the extra experience, which looks at that venture capital firms are coming together to pool resources and experience. But the heuristic could be that the partner firm, the partner VC, would have more research experience than the leading firm. Okay. And so basically, the success or failure is an important variation in this with plausible results. That is number 6. But we also allow for splitting the samples according to the stages of development. And we have simplified 3 different stages here. The seed stage, the early stage, the expansion stage, and the later stage. Okay. And the results are captured here in table 7. And what is still important is that the main arguments about extra experience, the main arguments about the tie and the trust are very important. And so the interaction between extra experience and tie. And some of the characteristics still play an important role, including the type of venture capital allocation and others. And I also want to allow for the final split. We also split the sample, taking into consideration the role of the China government in supporting state-owned enterprises. So we have this sample of, we split the VCs into SOE, state-owned enterprises, and the non-state-owned enterprises. Okay. And again, and that is trying to take into argument the argument of guanx, which leads to a higher profitability, better networks, lower risk because supported by government. But the results in table 8 show that experience, joint history, and reciprocated ties are all important factors when making decisions. But the magnitudes are larger for non-SOEs than SOEs. So these signals do matter more. These signals matter more if the potential partner is an non-state enterprises. And that's an interesting result, which possibly different from what would expected that the state-owned enterprise at VC would be much more important. Okay, so let me conclude after this long paper. Let me just conclude the remarks. Okay. Just about 5 points. One is that your network performs well to model VC partner selection. High prediction accuracy of 99.32. Okay. So our approach can successfully find plausible candidates for partner VC, which is the challenge that we are trying to address. We point out we are able to bring together characteristics which previously couldn't be put in one analysis, the industry experience, combining signals of industry experience and joint history of replication or trust, and those we find very important. We split the sample in 2 different stages of development, and we find that signal strengths include the likelihood of cooperation in later stages than in the early stages. We also split the sample into SOEVC and non-SOVC, and we find that signal strength matters more if the partner is not backed by the government. And we conclude that our approach can be utilized. This is the value addition of this research, that our approach can be utilized by VCs to find new partners. And this is a long-standing challenge problem that we hope we have solved. For future studies, I think future research should explore the possibilities of including some special characteristics that we didn't capture of partner VCs and the portfolio firms. For example, the VCs in the fintech space that has a high degree of dynamics. Also, it could be VC in the fintech space and a COVID-19 global pandemic. Thank you very much. Okay. Okay, I can see in the charts, let me look at the charts. Oh, thank you for generous comments, Oli. I may have missed this, but what are the objective of bringing a partner on board? The overall setting of this analysis is that a venture capital, selecting a venture capital partner under syndication is normally to address resource problems, to minimize risk and enhance value resources. But as you can see, the theories have been able to bring out other considerations which might be important, but mainly it is resource, pooling resources, minimizing risk, and that's information. And then Timo, thanks very much, Timo, for that. Why 10 and not 5 projects? Actually, in this algorithm, you could configure as many projects as you want. Okay. And
sorry, Victor.
yes.
Yeah.
Tell me.
The point of the question was why you chose 10. Is there any specific reason? I mean, obviously, in the algorithm, you could add 5 or 6 or 15, but was any specific criterion that you choose 10?
No, we didn't have any specific. We could have put in any number, basically. Yeah, we didn't have
Okay,
any.
so would this affect significantly the result? I mean,
Not.
if you choose 5, would this, for example, have an impact on the accuracy? My point is, the research, this paper is really interesting. But when I mean, this will be one of the questions you will probably have because you choose 10, but it will be better if you explain why 10 and not another number, because in that way you would give a better understanding for those reading the paper why you choose 10. I mean, I think it is important in terms of the analysis.
Okay. Thank you for this. I'll be generating. I'm just revising the paper, and we'll be putting it out for considered deeper comments. But let me say that in table 4, we actually allow for a lot more projects. But I will look into this and try to understand it a little bit more.
And I have a couple of more
Yeah, go ahead.
questions.
Yeah, go ahead.
Okay. The second question is, to what extent the results are universal? I mean, obviously, machine learning draws inferences from the data you use,
Yeah.
and the accuracy is certainly great. But would this technique have the same accuracy if you were using data from the US or Europe? Will the results be the same? Or is just subject to China and the way the venture capitalists may perform there, may make decisions there?
Yeah, I think that's a very good point, actually. Let me write it down. Because the way we configured the VC net, the way we configured the VC net is specific to China. Okay. So you are right that it will be the architecture of the VC net is specific to China. So it will be the case that the results could not be generalized, across the board. The only thing they could show is that with application to the VC industry in China, and given the high degree of being able to capture the data, that happened to be the case. Okay. So, but
Okay.
I think it could only serve as a motivation of modifying, because you have to modify the architecture of and that's what deep learning will be, and then the learning experience would be different for other countries. But I just acknowledge it's a very important observation that we need to make.
Okay, so another, sorry for the,
Yeah, please, yeah.
quite, another question is, you use a quite big, large time span, 1989 to 2016.
Yeah.
And I guess during this period, the way venture capitalists make decisions or choose their partners might have changed. And I'm not sure whether for a machine learning algorithm has a meaning to include in the results or the decision making process to reach the results. The way venture capitalists decided their partner in 1989 and compared to 2016, because what I think is this will affect for sure the results. So my point is whether you could, whether you have checked whether if you split these periods, whether you get different results, different accuracy, or something completely different.
Yeah. Okay. Yeah. We have done. That's a very good point. We have done the splitting of various parts of the sample, but not in terms of the time period, and that can easily be done. Yeah. There's no reason why not to do it. Yeah, I agree.
Yeah, I think that will be also good.
Yeah.
And
Yeah.
my final question is about the training loss.
The train. Yeah.
On the graph, so for example, when you repeat after some point, the training loss decreases significantly, but there is some points later where the 10 million times and 12 million times have spikes. Is there any reason for that? Because it's specific. For example, when you repeat it 10 million times, then there is a spike, then it drops, and then 12 million times it spikes again. Have you checked whether there is a reason why
No,
this
I yeah, I see what you mean. I think beyond the say iteration number 8 to iteration number 12, they're almost stable. But in actual fact, if you ignore the huge drop between iteration 0 and iteration 2, apart from that, there are simple variations with mean reverting. If you could draw a mean around there, it just would be simple mean reverting. Okay.
Okay.
So I wouldn't expect it to be, continue at 0. No. It would have to be so.
Okay.
It would have to show some fluctuations, but the mean reverting phenomenon, yeah.
That's fine. Okay.
But thanks very much for. Thanks very much. I'll definitely give you a version of the paper for reading. I think that there are actually 3 papers we are developing, and this is the first one, and my co-authors will be presenting the other 2 papers shortly, but we will generate one for deep comments and yeah. I thank also Juan has given that the VCs should be quite specific about the project's industries. It seems that their investment focus is missing here in the design. Okay. I think that's a very valid point. Yeah, because the VC, not only the focus of the lead and partner VC, but also the investment firms, the firms that receive the investment, have variations, and we should correct for the changes in industrial classification. Okay, and I think Christine agrees with that observation. Down uncertainty by only investing in areas where the non-industrial market. Yeah. We should experience. We can explore that for the investment uncertainty depending on the, and I think some of my previous work has shown that even in the UK, when you take the different sectors and you, so I will say in some of my previous paper, use reoption theory and show that actually the industrial classification does matter. So I think this is a very valid, welcome point. And then Yoshi, yes, Yoshi, I know you are working in this particular area, so thanks. I think that in order to reduce overfitting, using dropout in the layers might be helpful. Have you tried to make some adversarial attack, shuffle out some of the sample data to check robustness? Okay, that's a very good point. We have not. Yeah, that's a very good point, yes. Yeah. And then Athena makes a good point. Thank you for the interesting presentation. As you mentioned, Wanks is an important task for the Chinese VC market. I wonder if you would account for that in your model. Either so we only account for it in two ways, actually. When we are drawing to SOEs, and also when we are mentioning when we are mentioning the reciprocal ties, okay, our arguments in both are these yes. It may well be the case that we could capture Guanx in another form, okay, which we haven't thought about, but maybe kind of thing about this. Okay, so thank you very much. Any further comments? I don't see any hand up. Let me see. Oh, there is a hand by Juan. Hongbo, yeah, Hongbo hasn't. Hongbo.
0.1%. It's my turn. Yeah.
Yes, Hongbo. Yeah.
Thank you. Thanks for very interesting paper, Victor. It's very advanced. I learned a lot. My concern is, so you basically use, I think it's noisy. Somebody.
Sorry, I can't hear you.
Yeah. So I think that you started with a set of data from China, and then you applied a machine learning model to do the matching, the selection, for example, and then you found out actually your prediction is very accurate. And then you have the pair that you matched, and you do the further empirical analysis to derive some economic meanings. Yeah. So my concern is, if you start with the same set of data and you matched with 99% accuracy, you basically are using the same set of data for the regression analysis anyway. So I think big data, for big data analysis, probably you need another set of, or a much more bigger data, and then you do the matching without prior theories or distributions, and you match something, and then you can go further to do the empirical analysis. So my concern is, it looks like machine learning here does not really play any meaningful role, because you matched very well, and then you use this matched pair to further derive economic analysis. I do not know. Do you think this is something I found? Probably if you start, for example, with a much larger data, and maybe including other, countries, VCs, etc., transaction or something, and then you go back to China after matching, and you using the real thing to test your machine learning model. And that is my concern. And in addition to that, I think for the big data analysis, probably the narrative should be different as well, because we do not know the, for example, you mentioned a lot of theoretical predictions in terms of the features between the partners and the VC leader, etc., etc. But do we need to know that before you match them? So for the big data, after you matched everything, and then you can derive those and to show whether or not they are consistent with the theoretical prediction. So that's probably, that's something in my mind. And thirdly, another concern is, so in terms of, so you emphasized a lot on the advantages of having this kind of partnership. You emphasized that the resources depend, actual resources, uncertainty, etc., etc. But I think from the agency point of view, there are something that probably I do not know whether you ignore them deliberately or you just think they are not important. For example, if you bring more principles, let's say they are all principles, and there is a multiple principle conflicts in this kind of with syndication, let's say that way. Do you think so? So there is an agency theory involved as well, to me.
Okay, thanks very much for those well reasoned out comments on the paper. Let me say that first of all, that the machine learning, deep learning, neural network approach used here, as captured, say, in figure 1 I showed in the architecture of the VCNet, is simply to see how the model, which reproduces its own data when you start learning, because basically the starting points are those values, but it reproduces that data as you consider all the various nodes, okay? So it generates that data, is simply for working out whether the algorithms work and reproduce the reality. But after that, we then realize that basically, if you are interested in actually giving a quantitative value, a parametric value, the coefficients, the strengths of the relationship, the direction of the relationship, as well as the strength of the relationship, you would need estimated coefficients. And that's why we undertake that on the basis of the data and the variables that have been feeding into the ML process. Okay. So now, the two are reinforcing. Okay. The two are reinforcing. You know, for example, if it happened, and it would happen in objective research, that basically the ML, procedures do not validate some of these, strong relationships, or do not show a high degree of predictive accuracy, then it would be difficult to reconcile them with the coefficients generated from the estimate. The fact that they tally 100%, I think, is something about the achievement of this work. Secondly, I think you have a good observation on big data. It's possible that we could actually generate, okay, because there is a Gaussian artifact in there, you could actually have random numbers generating some new data based on observing that the moments of the generated data are consistent with the moments of the data we have, okay? And that could generate millions of data. You could get millions of data. So that's quite possible, okay? We haven't done so in this exercise, but that's quite possible. And the other third point is good, but I actually haven't thought about, to be honest with you, is how to how to think of the problem of a venture capital partner selection in a syndicate in terms of agency theory. We have drawn very much on signaling theory and others, but we haven't thought that maybe any of the partners, one is a principal and one an agent of the other. Okay, I need to think about, carefully, because maybe that's not how it works, because they are all like, as they fit in their own network, all the three major players, the lead and the partner and the investment firms. Okay. And so I would like to think very carefully and that might be right, that a agency theory could change the way this literature has been going for a long time. Okay. So you have given me good food for thought, and I thank you very much. Okay, I think I have Juan. Are you still there?
Yeah, I am. Can you hear me?
Yeah, yes, I can hear you very well.
Yeah, thank you so much, Victor. That's very interesting. And
I like
also,
your comment, by the way. I like your comment. I like your comment in the chat, and they have taken it down.
yeah, because so I haven't been touching this topic for quite a while, but I did have a project, as you know, in the past, particularly looking into the VC's investment and also their relationship with entrepreneurial firm. So it's really drawing my interest again, and then to think about the picture. And then the way how you're doing it, because I'm really naive about this kinds of neural network and machine learning, so it's really good, something that I can learn from your paper. So to add on what I mentioned about this kind of industry, it's not just about you talking about trying to differentiate the sample and to see what kinds of industry they have invested in, because VC in nature, they are quite focused investors, because they're not going to use their money and then put their money into something they don't know. So it's quite kinds of a niche investment decision. So the partner selection will be also quite narrowed, rather than they're trying to pick up because of whether it's a government-backed or whatsoever. And this is my first point, as I already put down in the panel. The second one is about the state-owned enterprises. To be honest, I'm not that surprised that it's not going to be that positive and significant. Because as far as I have known about state-owned enterprises, VCs, they have a different agenda, because they normally not just purely looking for profit, which the normal VCs definitely set as a priority. So they also have this kind of political agenda. So I have talked to a number of SOE VCs. They are more likely to be angel investors if we look at the different type and different nature of VCs. So it will be interesting, rather than thinking about their VCs, they're coming in later rounds, try to think about, oh, maybe I have already missed the points, that whether they come actually in initial rounds, which more likely they should be regarded as angel investors. And then SOEs are pretty much in that stage, to my knowledge. Yeah, that's pretty much my two questions. And then the last one is about, I'm not quite sure this paper is more finance paper or more, certain kinds for organization studies or whatsoever. So it really depends on where you're going to submit the paper, and then the research framing and also the theories. Because when you talk about China, and also I think the other commenters mentioned about, whether this is a really generalized study that can be applied to any context outside of China. Because to me is that if we look at VC in China nowadays compared with 10 years ago, that industry has been blooming quite a lot and has developed dramatically. So their behavior are pretty much like those in the other contexts, as far as I can see. So this could be something, the research setting that need to be reconsidered, and in order to generate more implications either for practitioners or theories.
Thanks, Juan. Much appreciated. And I think I'm gonna put this revision in my paper tonight, because we've been trying to work out precisely the interpretation of non-SOEs becoming important compared to SOEs. Okay, and you have actually nailed it quite well by showing the agenda, the political agenda as compared to the economic agenda of the state-owned enterprises, which goes back to conversation I had with Hong some time back on this. So that's a very good interpretation, actually, credible. But you have also added something to the concluding part of the paper. You see, the concluding paper, we are looking at further research. And this work has actually focused on VC partner selection and syndication. It sidesteps. In our data, we had data on, or there are observations on private equity. There are also data on angel financing. We sidestep those. So, Camden there is basically, whether, again, what are some of the issues. So it could be a possibility of, then again, a comparative argument using these methodologies to explore those other dimensions in PE and angel investor. So a good point in terms of identifying further research. Thanks, Juan.
Thank you.
Okay, where are we now? Okay, we have about 10 minutes, but Jun Hong on Guanx, I think he works in this area as well, right? But this paper, I'm going to revise. We're gonna polish some of this and take on some of these comments. And a good thing, I have a research leave, so you should see it in 2 weeks. We can circulate it for further comments and Center for Global Finance working papers. Okay, let me see in the list. No, I don't see any. Meng, do you see any list? Any?
No.
Okay. So let me conclude by thanking everybody for taking the time to come to this first seminar. We have a very exciting presentation next week by Christine Orton. Thank you so much, and see you next week, if not before. Thank you.